In a groundbreaking revelation, scientists have identified two narrow ocean regions in the northern and southern hemispheres that are warming faster than any other parts of the world's oceans. These rapidly heating ocean bands are not only setting temperature records, but are also emerging as powerful influencers of Earth's climate and weather systems. The implications of this discovery are vast, as the warming waters are already fueling more extreme storms, shifting rainfall patterns, disrupting marine ecosystems, and triggering changes that could lock in decades of future climate consequences. This video will explore where these hotspots are located, what's causing the intense warming, and how their effects are rippling across the globe. The two newly identified hotspots are located in mid-latitude zones, both around 40 degrees from the equator. In the southern hemisphere, the fastest warming band stretches across waters near New Zealand, Tasmania, and the South Atlantic east of Argentina. This southern band has been found to be the most rapidly warming ocean region on Earth. In the northern hemisphere, a similarly intense warming zone is emerging across parts of the North Atlantic, east of the United States, and the North Pacific, east of Japan. Though slightly less extreme than its southern counterpart, the northern band is also experiencing rapid and unprecedented increases in ocean heat content. These zones are not just geographically coincidental. Their positions around 40 degrees latitude align with critical atmospheric and oceanic systems, making them particularly sensitive to global changes and especially influential on worldwide climate patterns. Through deep-sea measurements and satellite observations, scientists have tracked significant changes in ocean heat content, the amount of thermal energy stored below the ocean surface. Since the year 2000, both of these ocean bands have been absorbing and storing heat at an alarming rate, outpacing the warming seen in other ocean regions. What makes this finding especially notable is the concentration of warming. While global oceans are warming as a whole, these mid-latitude zones have become particularly intense hotspots. Measurements taken from depths of up to 6,500 feet show that the warming is not limited to the surface, but is penetrating deep into the ocean layers, locking in energy that will continue to influence the climate for years to come. The rapid heating in these regions is not considered random. Scientists have linked the phenomenon to large-scale changes in the Earth's climate system, specifically the poleward shift of jet streams and the reconfiguration of ocean currents. These changes alter how heat is transported around the globe and where it is ultimately stored. The increase in greenhouse gas emissions, particularly carbon dioxide and methane, is the main driver of these shifts. As the planet warms, jet streams, the fast-moving bands of wind high in the atmosphere, have been moving closer to the poles. This shift affects weather patterns and changes the way heat and moisture move across the planet. Similarly, warming temperatures are altering the behavior of major ocean currents, which normally act as global conveyors of heat. These disruptions mean that more heat is being funneled into mid-latitude regions, where it accumulates in the identified hotspots. One of the clearest consequences of warmer ocean water is stronger storms. Tropical cyclones and hurricanes draw their energy from warm sea surfaces. As the waters in these mid-latitude bands heat up, they provide more fuel for storm systems, leading to more powerful and more frequent hurricanes, particularly in the North Atlantic. Increased surface temperatures also lead to higher evaporation rates, which pump more moisture into the atmosphere. This extra moisture doesn't just intensify storms, it also leads to heavier rainfall, increasing the risk of flooding during extreme weather events. The changing behavior of the oceans is also disrupting the way rainfall is distributed across the globe. With more water vapor in the atmosphere, some regions are seeing increased rainfall, while others are facing prolonged droughts. These shifts are driven in part by the way storm tracks, the typical paths that storms follow, are being nudged by the temperature gradients created by warming oceans. As storm tracks move, they can divert precipitation away from traditional agricultural zones and water supply regions, causing economic and humanitarian strain. The jet streams, already shifting due to climate change, are being further disturbed by the concentrated heat in these ocean bands. As the jet streams move poleward, they change the way heat and moisture circulate around the globe. These shifts have the potential to weaken key components of the Earth's climate engine, such as the Atlantic Meridional Overturning Circulation, or AMOC. This system is responsible for moving warm water from the tropics toward Europe and returning cooler water southward. A weakened AMOC could lead to colder winters in Europe, longer droughts in South America, and further instability in our global weather. Beyond large-scale patterns, the warming ocean bands are contributing to more frequent and severe regional extremes. Marine heat waves, prolonged periods of unusually warm ocean temperatures, are becoming more common, threatening coral reefs, fisheries, and the livelihoods of coastal communities. On land, adjacent continents are experiencing the heat too. Warmer air masses formed over the oceans are drifting inland, causing more intense and persistent heat waves. These events are becoming not only more common but also more dangerous, affecting public health, agriculture, and energy systems. Perhaps the most concerning aspect of this ocean warming is its long-lasting impact. The oceans absorb more than 90% of the excess heat generated by greenhouse gas emissions. Unlike the atmosphere, which responds quickly to changes in emissions, the ocean releases its stored heat slowly over decades. This means that even if global emissions were sharply reduced today, the heat already trapped in these ocean bands would continue to influence the climate. It effectively locks the planet into additional warming, creating a delayed but unavoidable impact on future weather and ecosystems. In conclusion, the discovery of these two rapidly warming ocean bands near 40 degrees latitude is a stark reminder of how deeply and unevenly climate change is altering our planet. These narrow regions, though only small parts of the vast global ocean, are having abnormally large effects on weather systems, atmospheric dynamics, and the delicate balance of marine and terrestrial ecosystems. Understanding and monitoring these hotspots is now essential, not only for advancing climate science but also for improving forecasts, protecting vulnerable communities, and preparing for the dramatic changes already happening. The oceans have long been seen as buffers in the climate system, but these new findings show they are also active agents of change, and we're only beginning to understand their full impact. Before you go, check out some of my other videos. Don't forget to hit that like button and subscribe. Thanks for watching. We'll see you at the next one.